Hello students, welcome to the Turito School Foundation program. Today we are going to deal the very important topic that is for the 7th class student. We are going to deal the physics topic that is related to units and measurements. Yeah, we would like to go for that measurement of microscopic and macroscopic physical quantities and conversion. It's very clear. We would like to go for that. Yeah, we would like to go for that measurement of microscopic and macroscopic physical quantities and its conversion. This is very important. We would like to go for that. Right, we would like to take that. Yeah, we can take that macroscopic physical quantities. Yes, their magnitude is very large. You can take that magnitude is large. All right. Now, if you are going to get that microscopic, yeah, we have to take that microscopic. Means very small. They are going to be getting that very small magnitude. Yes, if you are going to get that, the macroscopic changes are due to the microscopic changes. What you have been observed that the changes in the physical quantity are mainly due to the microscopic changes. That is very clear. Suppose if you are going to get the change of state, the microscopic particles, they are going to transfer the energy. If you are going to take that atoms, they will transfer the energy like that. So we would like to convert that one system of units into another system. That is going to be the conversion. It's very clear. Let's have a look. Yes, multiplication factors of the units, we would like to go for that. Right? Yeah, we have to use these multiplication factors, right? That is, if you want to express that value, you have to take that. Yeah. We are going to get that macroscopic value. Suppose if you are going to take that light traveled, yeah, we would like to go for that light year. We would like to get this one. Yeah, light year. So you have to confirm the distance traveled by the light in 1 year. Just you have to get that. Light in 1 year. All right. So if you are going to get that, it's a value which is going to be represented by that 9.46 into 10 to the power of 15 meter. So we are all going to get this one. This is going to be that multiple. Okay. So it has been estimated that is 9.5 approximately equal to 10 to the power of 15 meter. All right. And also you can get this one 9.5 into 10 to the power of 12 into 10 to the power of 3 meter. All right. So you will get that value 9.5 into 10 to the power of 12 kilometer. You know very well about this matter. If you are going to get this one, so easily you will get that 10 to the power of 3 meter, that is going to be 1 kilometer. It's very easy for you. You can represent that value. So we are going to get that multiplication factor, that is going to be 10 to the power of 12 of unit. You can take that. It's very easy for you. You will get that. Like that you are all having that. You have been raised that the base that is going to be getting that, the power of that base is going to be identified 10 power 12 like that. If you are going to follow the order, just you have to see 10, 10 power 2, 10 power 3, 10 power 9 and 10 power 12, 15. Yeah. This is all about the multiplication. While you are going to have the submultiplication also, you are getting that the large value, you are all getting that large value. They are going to be the macroscopic parameters. So, if you are going to get this microscopic, easily microscopic, yeah, that is, yeah, atoms. The measurements related to the atom, you have to get that. While you are going to talk about that size of atom, radius of atom, yes, they are going to be very less, you have to get that. So, 1 angstrom unit, if you are getting that, that is you have to represent with the 10 power minus 10 meter. So, if you are going to look into that matter of that atom, you have to identify that this is the nucleus, this is going to be the atom. You will get that angstrom units. If you are going to get that 1 Fermi, you have to represent that, that is 10 power minus 15 meter. Easily you will find out that, it's not a matter, just you can take that. This is very less, you have to take that. Okay, you are all getting that. The microscopic phenomena, which is going to be represented by the submultiple, that is going to be 1 by 10 to the power of 15 meter. You can take this one, this is very clear, you can get that all. Okay, all of you, you have to identify that. You wants to represent that microscopic physical quantities, that is the radius of atom, radius of the nucleus, all these are all identified, alright. So, we would like to get that speed and we are able to gigabyte. Just you are going to measure the speed, you are going to get that, measure that memory. Just you can take that frequency megahertz, yeah, 10 to the power of 6 hertz. 1 megahertz is equal to 10 power 6 hertz. You wants to get that 10 power 3 kilo, yes. If you wants to measure that resistance or any physical quantity, you have to take that these multiples. You wants to represent that large value in terms of a specified unit. Just you have to take that 1000 ohms, that is 1 kilo ohm. Yes, you can take that mega ohm, mega frequency, gigahertz. Yes, you have to get that high frequency. The value which is going to be represented with the suitable one, you have to take this one, right? Yeah, we are also going to have that frequency what we are having the communication. Yes, we have been crossed that radio frequency. Yes, we are going to get that high frequency to get that transmission of the data at high speed in the communication system. Yeah. Right. Okay, we are all going to discuss about all these multiplication factors and their unit. We have to take this one, right? Yeah, deca, hecta, kilo, mega, and giga, tera, peta, exa, all these are going to be having their names and their symbols also represented. Let's have the submultiples. Yes, you are going to get that submultiplication factor. Let's talk about this one. It's very easy for you, you can get this one. Yeah, you have to get that 10 millimeter, that is 1 centimeter. Just you will take that 1 mm is equal to 10 power minus 1 centimeter. Yes, this is also useful for you to get that representation. At the same time, if you want to represent the small value, you are going to take that their magnitude is going to be very small as compared to the macroscopic parameters. So, clear all about this one. Now, you can take this one, right? You know, 100 centimeter is equal to 1 meter, right? 1 centimeter is equal to 10 to the power of minus 2 meter. Just you have to get that. Yes, 1 centimeter. Just we have to take that. That is going to be 10 power Just you wants to take that whenever we need the representation of the microscopic phenomena, which of their magnitude is going to be very small, we can get this one. Right? You wants to tell the dimension of the bacteria, the size of bacteria, virus. Yes, you have to look into that matter of that range, that is going to be 10 power minus 6 micro, nano, pico, femto, octo. Just you have to take all these, right? Suppose if you are going to get that, this is about that conversion. We are going to use this conversion, right? Now we would like to go for that. We would like to get this nano, yeah. Nano. It's going to be 10 power minus 9, yeah. 1 nanometer. It's going to be 10 power minus 9 meters. Just we would like to go for that. We are all getting this one, right? At the same time, we can go for that pico. While you are measuring that pico farad, capacitance of the capacitor, you have to get this one picofarads. While you are getting that measuring of resistance, voltage, current, milliamperes. Now, if you are going to get that study of the semiconductor devices in higher classes, you are going to get that measurement of the current, it is going to be very less. You will get that, yeah, it's going to be, yes, milliamperes. Yes, you will get that. So, you have to take that current through the semiconductor diodes. Yes. So, if you are going to get that the current, the magnitude of current, it is going to be very less. In forward bias, it is going to be microamperes. Just you have to get that. Depending on the magnitude, we can choose that submultiple factors to represent that micro, milli. Yes, we are getting the output through the semiconductors. That is very less. So, based on that value, we are going to use the suitable. Suppose it is going to be 10 power minus 3 amperes. Just you will get that milliampere, 1 milliampere, microampere. Just millimeters. We are going to talk about that size of the bacteria and virus and all these things were very less. They are going to be having that microscopic observation. Like you have to represent the value with the help of these submultiples. All right. We would like to get this microamperes. This is, you are going to take that diode. Yeah. If we are going to get that input and output, yeah, it's current in forward bias. Just we would like to get that. You would like to get that in a higher classes. You can learn all these things. Just we have to know about this parameter, and this is going to be milliamperes. Yes, yeah. If you are getting the input and output, we would like to get that microamperes. So we are going to get that very less output under reverse bias and forward. Later you can know all these things, but the thing is, whenever you have given the input, if you want to measure that one physical quantity which is going to be very less, at that time we used to get that submultiplication factors of the unit. Alright, like you have to take that. This is going to be 10 by 6 multiplication. Just we have to take all these things. Okay. Yeah, in your real life, we are all going to take the advantage of these submultiples and multiples of units to represent the physical quantities of microscopic and macroscopic. Can you guess that what is that weight, what is the size of that microscopic organism? Just you will get that, na? All these are going to be getting. Let's go for that, some model problems based on this, and in your real life you are using all these things. While you are going to measure that thickness of hair, it's going to be mm. You can have the different case studies in your life also. Yes, no. 1 mm thickness of the stone, what is the size of that 1 mm to 2 mm of that stone? It is going to create the panic pain. That's going to be the stone in the kidney, human being. They are going to be suffered a lot. That's what. If you are going to talk about that size, it's going to be having that microscopic observation. And they are going to eliminate, they are going to estimate that size. And they are going to execute the suitable operation to get that elimination, right? Okay, in our daily life, we have to consider that submultiples of the factors of the units and multiple factors of the unit. Yes, we cannot isolate all these things in our real life. They are also having that, right? Okay, let's have a look into that matter. We would like to go that. So this is a very simple method to get that units of the capacity. We would like to get that. You know, generally if you are going to take that liquids, they are not having the shape. They are going to have the shape of container. If you have to get the measurement, yes, if we are going to have that measurement, that is going to be liters or kiloliters, and like that, they based on the capacity we would like to get this one, kiloliters, right? Hectoliters, decaliters, just we would like to get this. So if we are going to get that measurement of that liquids, it's 1 kiloliter, that's going to be 1000 liters. Just we will take 10 liters. 1 liter, 1 by 10, where we are using that. This is about that multiple. Just we have to see, this is going to be getting that multiple. That is of 10 power 3, 10 power 2, 10 power 1. This is very clear, 10 power 0. We are all going to have that representation. This is going to be submultiplication. Just you have to see submultiple factor, submultiple factor, that is 10 power minus 1, 10 power minus 2, 10 power minus 3. In this way we are going to represent. It's very clear. If we are going to get that 1 kiloliter is equal to how many liters? 1 hectoliter, just we have to take that 10 power 2, 10 power 1, 10 power 0. It's very clear. We are going to get that deciliter, centiliter, milliliter. We are going to get that to estimate that concentration of the solutions. We are going to get that their measurements and their intensity, which is going to be added. It's very small. That is going to be in milliliters. That can produce that drastic changes of the chemical properties. Yes, if you want to estimate that the chemical properties of that any material, just you have to understand that what are the compositions that we can add to create the drastic changes in their chemical properties. Just we can take that. This is going to be the milliliter. It's very clear. We are having that. Yes, yes, just you have to see this is going to be identified. Yes. You are all going to get that now. We have to rise that. This is going to be getting that. This is going to be like that, ml. What we have reached from kiloliter to milliliter. Yes. You can take that. This is going to be the 1, 2, 3, 4, 5, 6. So you have to get this direct conversion. If you want to get that direct conversion, we have to take that 10 power minus 6 ml. Yes, if you are going to get that, yeah, if you want to have the conversion from kiloliter to milliliter, just you have to take this table is very useful for you, right? And if you want to get that conversion from here, you have to take that. Yeah, in this way you can take this, right? like that. You have to take that 10 power minus 5. We are going to get this conversion. You want to convert to any desired system of unit, just you can take that. You can take that submultiple. Suppose you want to take that 1 ml, just you have to take with another color. You want to express that 1 ml, that's going to be 10 power 6, 1 ml. Just you have to take that. It's going to be having that, right? Just everybody has to look into that matter. Yeah, it's very useful to get that conversion. Easily you will convert that. You want to express that 1 kiloliter in terms of milliliter. Yeah, we have to take that 1 milliliter in. So the representation of higher order into lower order, just you have to take that in terms of 10 power multiples. In terms of multiples, we would like to get that. In terms of submultiples, we would like to represent that the value of the physical quantity, lower value in terms of higher. Just we have to see, this is going to be getting that carried 10 power minus 3. Yes, 1 gram is equal to how many kgs? 10 power minus 3. Right, 1 kg. From higher to lower, we are going to get that grams. That is going to be 10 power 3. So in this way, these are all very useful. We can use all these multiplication and submultiplication factors of units. We would like to execute that practical session, and also we would like to make the use for the conversion of units from one system of unit to the another one. It's very clear. So you have to get that. While you are moving from high order to the lower order, we would like to go for that multiplication. Yes, right. Lower order to higher order, just we have to take that submultiplication. It's very clear. Well, you want to get that now 1 milliliter, just 1 milliliter to 1 liter is equal to how many milliliters? Just we have to take that from here. We have started 1, 2, 3. That's what we would like to go for that. Yeah. In this way, we would like to get that. Yes. That is going to be 1 by, yeah, you have to take this one. If you are moving that 1 liter, that's going to be that 1000 ml. Just we have to take this one. You can convert 1 milliliter into kiloliter. It's easy for you. 1 kiloliter into milliliter. That is higher to lower. Just we have to get that multiples. It's very easy for you. Lower to higher, submultiples. We have to use that submultiples. It's very clear for you. Easily we will solve this one. Yes. So in this simple method we can divide that. Let's have that. It's going to be, yeah, we are going to get that all. Just we would like to go for this one. Just we have to see this is going to be identified. Yes, everyone has to identify this one. Yeah, you want to get this from milliliter to the centiliter. Just we have to divide with the 10. Yes, in this case, this is going to be the multiple. This is going to be the submultiple. We have to see. We are going to have that very good observation. That is, so we would like to go for this one. Yeah. Yes, you have to see. Let's have the look into that matter. Yes, everyone has to identify. Let's see. You want to get that conversion ml to centiliter, just you have to get that, divide with the 10, like that. This is going to be the submultiple. This is going to be the multiple. Yes. 1 centiliter is equal to how many milliliter? That's going to be. 1 liter is equal to how many? That 1 liter is equal to 10 to the power of 1, 1, 1. Just you have to get this conversion, that is 10 to the power of 3 ml. 1 liter is equal to. Like that, you have to practice it. While you are going to use the make, that is going to be the submultiple, right? Representation of that lower order into the, in terms of higher one, milliliters into centiliters. You have to divide with the 10 and get this one. Again you will get that. So you want to convert milliliter into liter. Just you have to get this one. Decaliters. Just you would like to milliliter into liter. So in this way you can practice and you can use all these things. Easy way to remember the units of conversion. Here you are all going to have that. Just see here, that is going to be the K. Just you have to get that. This is going to be the HD TV. This is going to be that LG company logo. Yeah, LGM. Just we have to get the DCM. Just you have to get that. Right, kilo to M. Just we have to take that HD. Just we have to take that kilo to this order. We would like to represent all these things. Yeah, just you have to take that. We would like to have the conversion, that is going to be that length. We are going to get that mass. We are going to get that distance. Yeah. Yes, kilometer, hectometer, decameter, millimeter, centimeter, decimeter, all what you are going to get this one. This is, in this way we would like to go for this one, right? We would like to take this one. This is very clear. HD TV, just we would like to kilo, just we have to take that K, H, yeah, we would like to use D, and we would like to LGM, yeah, we would like to, this is going to be that logo LG, yes, liters, grams, just we would like to meters, that's going to be the distance, that's going to be the mass, that's going to be that volume, just volume, that is for the liquids, that is for solids. We have the measurement. Okay, all right. Let's go for this one. This is very useful for you to remember very easily. Just you have to get that LG. Just we would like to get the TV, HD TV of that LG company. It's going to be carried by the TCM. Yes, it's very clear that gives the happiness symbol, right? It's very clear they have the some relation. DCM, LGM, just HD TV, it's going to be that K. All right, it's very clear, we would like to go for that. In multiples, we are going to get that, what we have discussed. So, everyone has to look into that matter, submultiples also. So, we would like to make the use of all these multiples and submultiples. Okay, it's clear, we would like to go for that. Yeah, you are going to get the decameter, hectometer, kilometer, and submultiples also. We would like to go for that, right? Yes, multiples, kilogram. Just we would like to get that. Just we would like to get that. This is very clear. We would like to go for that. Yeah. We can use all these things, just we would like to go for that. We would like to go for that units of length. Yeah, kilometers and the meter, we would like to go for that. How we are going to get that? 1 kilometer, 1000 meters. Just you have to get that. This is going to be 10 power 0 kilometer. 10 power 3 meters, right? Again you will get that meters to centimeters. centimeters to mm. So you can get that millimeters to micrometers. Yeah, you are all going to get this one, very clear. In this way we can have the conversion. So in the coming class we would like to discuss about that conversion of the units, especially we would like to take that base units. After that we would like to go for derived units and its conversion. Thank you very much. Have a nice day.